Keep writing. Today, we're going to talk about similar transformations. How can we use properties or transformations to determine whether figures are similar? Draw and describe similar transformations in the coordinate plane. Ooh, sounds fun. Use properties of similar transformations to determine whether polygons are similar. Our key term today is, of course, similar transformation. But here in just a little bit, I'm going to move on for now, though, okay?
What time
Hi.
are we going to take that plane?
9:35. Transformation that produces similar figures, of course, is called a similar transformation. Similar transformation. Here's the key. A similar transformation is a dilation, or it could be a composition or a composite of one or more dilations and one or more congruent transformations. So basically, what you need to get out of this is the fact that when you change the size of a polygon, you have a similar transformation. Even if I have a dilation and then a translation, right? See what I did there? Dilation changes the size, correct? Right? A dilation changes the size. Okay? So if I go dilation, translation, I've got three different figures. The original, the pre-image, the actual dilation, right? And then the translation. Okay? If I'm comparing, what's wrong, balls?
Oh, I thought you were going to go.
Oh. Okay? Two figures are similar if and only if there is a similarity transformation that maps one figure to the other figure. Right? We got to get this, make sure we understand the verbiage, we got to make sure we understand everything about it, okay? There is a big difference between dilations and the congruent transformations we just studied in Unit 1, right? I hope you guys will see and understand that. That is our big picture idea, okay? It's just like when we look at my rectangular, what do we call that thing back there? Board, thank you, right? And I compare that rectangular board to this concrete block. They have the same shape, but they have different sizes, right? Okay? Y'all with me? All right. Cool. What do you mean, Mr. Hobbs, when you say dilation? Here's what I mean. Apply a dilation, D, to the polygon with the given vertices. Describe the dilation. I want to take the original XY, apply a scale factor of what?
33.
So Mr. Myrick, in our warm-up, when you were saying, why? Because you asked. And it's a good question to ask.
Oh.
In our warm-up, when you said, Mr. Hobbs, I'm multiplying there, how do I know what kind of transformation this is? When you multiply your coordinates, you've got a dilation. Promise. You could have a stretch. You could have what's called a horizontal or a vertical stretch. If I took this away, okay, and I was just saying 3x comma y, we call that a stretch, right? You don't know that, so you wouldn't say right.
Yeah, I know.
We would call that a horizontal stretch, okay? We're not going to worry about those yet. We'll worry about them like in May, okay? But right now, we're not going to worry about them. So, all I got to do is I take each of my coordinate points, plot those points, 1, 1, 3, 1, 3, 2, multiply every coordinate point by the scale factor. 3 times 1 is 3. 3, 3. 3 times 3 is 9. 9, 1. 2 times 3 is 6. 9, 6. You'll see this? The A and A prime, the B and the B prime, the C and the C prime. That's all you're doing. It should be incredibly simple, right? Y'all hear me? You should look at this and be like, I got this. I can get this. I know I can get this. and you can. Okay? Apply a dilation. What's the scale factor? Recognize the scale factor. What is it? Identify. Somebody identify for me the scale factor.
It's fraction.
3/4. 3/4. Numerator smaller than denominator. Bigger than 1 or smaller than 1?
It's would be.
Smaller than 1, because 4/4 would be 1, right? 3/4 is smaller than 1, so what's going to happen to this figure?
It's going to shrink.
Going to
Reduce.
reduce, right? Good. It's going to shrink, which we call a reduction, okay? All right. So if I have these original points, I multiply everything by 3/4. I get my prime points. I've applied my scale factor, and I'm good. Okay? Yes, ma'am.
What does the center 0, 0?
Okay? The center of 0, 0 means that is the point from which the dilation occurs. All right? And we will change this up a little bit, but for the most part, we'll have a center at 0, 0. Okay? So if I had a center at, let's say I took this and I had a center at 0, 4. Okay? Then the dilation would be how far is each original coordinate point from 0, 4. Okay? Understand that as it stands right now, all of these points are based upon how far they are from 0, 0, right? See what I'm saying? Hello, thank you, ma'am. When I plot these points, I'm starting at 0, 0, going 4 to the left, 4 up, correct? I mean, that's how we teach you guys to plot points. If I have a dilation that's here, that's basically telling you I am no longer using this as my starting point. I'm now using that as the starting point. It's a whole separate lesson, okay? But it's a great question. Right, I want you guys to do this one. Apply the dilation for me. XY such that I take a scale factor of 1/4 and apply it and make that dilation. Name the coordinates of the image. Describe the dilation. So here's what I want.
How can I describe it?
Because I'm about to tell you how, okay? Name the coordinates of the image. In other words, you're going to have D, E, and F. When you name your coordinates, D prime, E prime, and F prime, right? Remember that rule about transformations? The pre-image is D, E, and F, and then you apply your dilation. When you name your coordinates, it's called D prime, E prime, and F prime. Mr. Myrick, when you describe the dilation, real simple. Enlarge or reduce. That's all you gotta do.
So it ain't like reflection.
Okay? Well, what is it? It's a dilation, right? It's a dilation. It's a dilation. Thank you. Okay? So all I need to know is, did it reduce or did it enlarge? Alright, let's see if we can get this done. Alright, hey guys, started off by writing down the coordinates of D, E, and F. Shouldn't be hard. I'm just copying down what's already up there. -8, -4, and then -4, -8.
I didn't see that.
Yeah. Okay, I'm going to take each of those coordinate points, multiply them by 1/4. Alright? So that's all the way through. Here's what you should have written down. D prime, E prime, F prime. 1/4 of -8 is what?
-2.
-2. So this would be -2, 0.
Zero.
1/4 of -4 is what?
-1.
So this should be -2, -1. And,
-1, -2.
okay, for those of you that were wondering how I do that, here's how. In my calculator, I type 1/4 times -8.
I done -8.
1/4 times -4. That's all I gotta do, right? Last part I gotta do is describe the dilation. What happened from here to here?
It reduces.
Reduce. Reduce. by a fourth if you want to get, you know, the full credit. Right? Yes, sir.
So like, since it's like 1/4, can you not just divide it by 4 and use that same thing?
You know, if you want to talk about how we multiply fractions, we can do that, but it's going to be at a different time. I mean, you could. What if I said 2/3 and you start dividing
Yeah, I
by
mean, I
3?
understand that. But I'm
And then I
saying,
go,
like, if it's
wrong!
No, I'm saying like if it's 1/4, like.
Yeah, I mean,
if
good.
It's 1 whatever it is.
You can do
whatever
that.
it is, it's just divided by whatever the bottom is.
Can I have notes for Tuesday?
You can. They're on Ed Motor.
And can you also tell me where I'm at?
I can, sure. Let me tell just you or everybody. Just you? You sure? Don't tell everybody?
Drug deal.
Drug deal? Yeah, good. Alright. Determine whether the polygons of the given vertices are similar. Whoa.
They're not.
Whoa. Now, this is a different animal, right?
Yeah.
Now, all of a sudden, Phil, all of a sudden, what do I have now? I've got two different figures. I got two different figures plotted, and the question is, are they similar? Remember, this goes back to yesterday. If they're similar, they'll have a similarity ratio, right? And that similarity ratio is going to be the same amongst all sides, okay? And if the similarity ratio is the same, those sides are proportional. Ah, see, that's why yesterday is important, okay? Okay, the angles are congruent, these sides are proportional. How does everybody do this with me? Ready? 1, 2, 3. Proportional. Okay? Why am I saying it like that? Because later in the semester we'll come back to this and I'll say, guys, they're proportional, and you'll go. And I'll say, alright? So here's how y'all are all like, okay, I get it. You're an idiot. But how do you get the answer? Just like we did yesterday, okay? It's just like we did yesterday. Or for some of you, we get the answer through math, all right? Guys, I need to figure out the ratio between AB and JH.
1, 2.
AB, JH, okay? Got me? That's one thing. And then I'll take the ratio for AC over JK. Okay? AC over JK. Y'all see where this is going, right?
I can even count.
Well, we'll help you with that. Okay? Let's see what it is. AB. 1, 2, 3, 4, 5, 6, 7, 8, 9.
It's 4.
JH. 1, 2, 3. You're right, you can't count. Okay?
Oh, it goes.
3. Alright? AC. A to C. Here we go. Ready? Cameron? 1, 2, 3, 4, 5, 6, 7, 8, 9. Hot dog.
Next one's gonna be 3.
Alright, good. And J to K is, for some of you who can't tell, is 3. Alright? So far, is it looking good for us?
Yeah.
Yeah, it's looking real good, right? As a matter of fact,
You divide.
guys, if you can't see it,
It's just.
here's all that you have to do now, okay? Just do the other two sides. CD over KL and DB over LH, right? Do you have to? Yeah, because you're good students, all right? And it could be another type. This is an easy example, okay? So yes, you have to, all right? But let's talk real quick. So CD is going to be 9 over. CD is going to be 9. KL is going to be 3. But DB is going to be 9, and LH is going to be 3. Okay? Everybody with me? You'll see how I set them up like this. The work may have it a little different. Y'all just be prepared for it. What is 9 over 3?
3.
3. Or, in case you want to know, it's 3 over 1. Is this the same?
I can't see.
Yeah.
Is that the same, Cameron?
Yes.
Okay. Oh, what do we say?
Proportional.
Right? Alright, now, hey, let's see if we can get this part, because this is the, okay, you know what, we've done, I told y'all, I said, y'all do this for about 2 or 3 days, and you'll get it, right? Okay? Hopefully seeing it today, now, maybe it's boring already, which is really good, but maybe, if it's not boring yet, maybe you're following it a little bit better, okay? Alright. The work's not quite done, okay? Here's why. If I went from JKLH to ACDB, what was my scale factor?
3, 3. Well, I hate you so much.
Is 3, 3 a scale factor or coordinate points? Sounds like you're trying to do
Or no,
coordinate points.
it's 3x
And?
and 3y.
Perfect. Y'all see what he said?
Nope.
Okay.
I got it.
The scale factor would be 3. I multiply each of these coordinate points by 3, and I would go and make that figure bigger, right? Go with me? Hey guys, y'all aren't listening and you're not gonna learn. Okay? If I took each of these coordinate points, Cameron, and I multiplied everything by 3, I would get the coordinate points of A, C, D, and B. Ah, that's how we get a scale factor of 3, right? Okay? Do I? It doesn't have to be. It's still at the origin. And that goes back to a different, you and Hannah must have like been texting or something behind my back, okay? It's a different question. It's centered, I promise, okay? It doesn't have to be perfectly centered at the origin. It's the distance from the origin that matters. Just, for right now, just trust me. Just, I know, it's early in the year, and it's still like, are you sure? Guys seem kind of crazy, right? I promise it'll all work out. Hey, here's the bigger question. Miss Tabor, I haven't called on you yet. If I go from ACDB down to JKLH, what was my scale factor? Take a guess. I won't make fun of you, I promise. I can tell. We're thinking. What are you thinking? Tell me what you're thinking. Well, you're thinking something, because you're looking at it. If I go from here down, how do I go from these coordinate points down to these?
Would it still be 3?
Okay, so it's not 3, because what would happen if it were 3? I would go from here up, right? So, this is why I did this. Guys, if you go from a bigger figure and you reduce to a smaller figure, you simply take the reciprocal of your scale factor. Okay, you take your reciprocal of your first scale factor, right? So if this was 3 or 3 over 1, I can take 1/3.
If you did C and D, right, if you did L, it would be different because it's at a different spot, wouldn't it?
What's 1/3 of 3? 1/3 times 3. 1. What's 1/3 times -6? -2. So if I did C and K, I'd get the same thing. Alright? Alright. Hard problem. Okay? That's not an easy one to see. I think I'm seeing that. You want something that's off the origin a little bit, maybe. I don't know. Maybe you do, maybe you don't. Okay? Same question here. I want you guys to look at this one and get started on it. Okay? Just get started on it. Oh, the first thing I'm going to do, guys, is compare to see if there's similarity. I got to determine if there's proportionality. Right? You understand what I mean when I say that? I've got to determine if there's proportionality. Mr. Hobbs, how would I do that? Good old-fashioned digging. Let's go QR over XY. Y'all got me? QR over XY. Okay? How far is it from Q to R? 2. How far is it from XY?
3.
Alright, now let's go this side. RS over YZ. 1, 2, 3, 4 over 10. Okay? 4 over 10. Right? Okay? Now, 2/3 is going to reduce to what? 2/3.
Oh, heck no.
Right? What's this going to reduce to?
2/5.
2/5.
So no, they're not proportional.
Okay? 2/5. Right? Well, here is our thinker about proportionality. Okay? Did this side increase the same as the side opposite it? Yeah, it did. Did this side increase the side opposite it?
Yes.
Yeah, by the same, right? Okay? So this will get us to our next level of proportionality. Okay? What is the scale factor that I apply to go from 4 to 8? 2. Right? I apply a scale factor of 2. Okay? What scale factor would I apply to go from 2 to 5?
None.
2.5.
I
Right?
didn't know you could do
2.5.
You can't do that one, can you? Well, you can do decimals, but if I apply a scale factor of 2.5 to get here,
Yeah.
and I apply a scale factor of 2 to get here, is that good enough?
No. Because you.
Well,
I don't know.
yeah.
You're the math
See,
teacher.
you're right, I am. And so here's the issue with it. As long as I am moving the same direction, okay, I am okay with that. All right? As long as it's moving the same direction, and this is where I was talking about my stretches, okay? As long as I am moving in the same direction with my scale factors, that's okay from a proportional standpoint. All right? So, in this particular situation, I want to look at the opposite side. What is the side opposite of RS? QP. QP. What is the side opposite of YZ? XW. Okay? Check those out. How far is it from Q to P?
3.
Nope.
Oh, wait. Oh, no.
4.
How far is it from X to W?
10.
10. Okay? How far is it from, what side's opposite QR? PS. What side is opposite XY?
WZ.
WZ.
Yeah.
How far is it from P to S?
Wait.
2.
2. How far is it from W to Z?
10.
3, right?
WZ. Not bad.
Okay? From W to Z, it is 3. Thanks, Cameron. Okay?
Mr. Hobbs.
I know, right?
Let me know when you need
Okay.
a new teacher.
With rectangles. Say what?
I said, let me know when you need a new teacher.
I will, bud. Alright? with rectangles, The key is determining whether or not the opposite sides are proportional. Okay? With rectangles, I want to know if the opposite sides are proportional. Okay? So, in this particular case, I've got proportion amongst the opposite sides. If they are rectangles, all of the angles have to be what? The same. Take it to the next level. Not only are the same, they are how much?
Equal.
How many degrees?
Oh, 90.
90. Okay, very good. Okay, because they all have to be right angles. Right?